Okay, so today we're going to solve some systems of equation word problems. And more than anything, I need you to learn the process, guys. So first thing you want to do is just read the whole problem, understand what you have to answer. So I'm going to highlight a few things as I'm going, okay? So we have this example number 1, and it says Vidal watched 6 times as many hours of television over the weekend as Deneen. Together, they watched a total of 14 hours of television. How many hours of television did each person watch over the weekend? That last sentence I'm going to highlight. It's a little challenging. Sorry about that. All right, so it asks us how many hours of television did each person watch? So that's going to determine our variable because we have 2 people, right? We have Vidal. So I'm going to use the variable V as in Victor, or this V. The V for victory. And that's going to equal, we're defining a variable. You have to do this each and every time. It's going to represent the number of hours Vidal watched. Number of hours of TV he watched. So number of hours of television Vidal watched. So go ahead and write that down. Go ahead and write that down, please. So that's one of the things we have to answer. And the other one, we'll use the variable D for Deneen. Specifically, number of hours of TV that Deneen watched. Okay, so first task, read through the question, understand what you have to answer. That'll take you to what the variables will represent. So now that we have that, we'll do a reread, and we're going to draw out 2 equations. Okay? So we're going to read from the beginning and see if we can't get one of the equations. So it says, Vidal watched 6 times as many hours of television over the weekend as Deneen. Okay, there's one equation right there. Vidal watched 6 times as many hours of TV over the weekend as Deneen. All right, so Vidal watched more TV, right? How much more TV? 6 times. So the amount of TV Vidal watched, which is V, equals, well, 6 times D, 6D. 6 times as much as Deneen, so 6D. So V equals 6D. That's our first equation. All right. Now, any questions on that? So that gave us one equation. The next sentence is going to give us a second equation, and then we can answer what we have to answer. Okay. So it says together they watched a total of 14 hours of television. So together, they watched a total. Important words going on there. What do we do when we total stuff up? Add. So what are we adding here? Yeah, how are we? And we're representing those hours with these variables. So the number of hours Vidal watched plus the number of hours Deneen watched equals how much? That's the total number of hours. 14. So that's our system of equations. V plus D equals 14 is the second one. So we have two variables. So we need two equations. We got them now. We can figure out the answer. Okay. Let's use substitution. I want to use substitution because I have that first equation that says V equals 6D. Yeah, we're going to substitute this in here. So let's do that. Let's solve it. I'm going to take this and rewrite that as, instead of V, it's 6D plus D equals 14. And we'll take it from there. Let's combine 6D and D. That becomes 7D equals 14. We'll divide out the 7. And you get 2. D equals 2. But D equals the number of hours Deneen watched. Oh, you're ahead of me. Hold on. So we got part of our answer. We'll take V equals 6D, replace D with 2. That's going to be replaced by 2. Because now we know that that's 2 hours for Deneen. So Vidal watched 12 hours. So let's go ahead and write a sentence to answer the question. So we can say, Vidal watched 12 hours and Deneen watched 2 hours of television. So today we're just gonna we'll do the whole process, but we're only gonna focus in on today's assignment on reading, setting up some variables, and writing the two equations. Okay. All right. Let's move on to the second one. You guys ready? I still see a few people looking and writing. In the meantime, I'm just going to read the example number 2. Lucida is a cross-country ski racer. On Saturday, she skied twice as many miles as she did on Sunday. Over the weekend, she skied a total of 63 miles. How far did she ski each day? How far did she ski each day? So the question is asking how far she skied each day. What are the days that we're talking about?
Monday.
What are they?
Saturday.
Saturday and
Sunday.
yeah, Saturday and Sunday. So I can't do S and S though, because they both start with S. Let me just do X and Y.
42 on Saturday.
Okay.
42 on Saturday.
Okay. Let's see. X is number of miles skied on, what is it? Saturday. And Y is going to be the number of miles skied on Sunday. Okay. So write that down. So let's go back, reread it, and add. We'll add a it says on Saturday she skied twice as many miles as she did on Sunday. So what day did she ski more miles? Saturday or Sunday? How many more? Twice as many. So Saturday on our variables is X. X equals, how would I write that? X equals what? If we want to show that it's twice as many on Sunday. Saturday equals twice as many. Well, we need a 2 because it's twice as many. Twice as many is what? 2 times what? 2 times Y. Because that's Sunday. So Saturday equals 2 times Y. X equals 2Y. Okay?
What?
Please put that away. Focus on this.
It was this. It was on the phone.
So let's resume. Over the weekend, she skied a total of 63 miles. Over the weekend, she skied a total of 63 miles. How would we total that up? The miles. What do we do when we total them up? Add. So we got to add. When it says total, we got to add it. What are we adding? Yes.
Well, I don't know. Can't you just divide 63?
Well, I want to set up equations. I want to do it this way. So what are we totaling up? Use the variables. We're totaling up Saturday and Sunday. And that has to equal 63. Okay.
Isn't it 6.3?
No, it's 63 miles. All right. Well, let's solve this by substitution. So it's going to be 2y plus y equals 63. Okay. let's see, that's 3y equals 63. Divide, yeah. And so we get 21 there. Okay. So it looks like on Sunday it was 21 miles. So now let's take the fact that she did twice as many on Saturday to get,
Like I said, 42.
it's the process we're learning here. Because they're not always going to be this easy. But if you got the tools to set up any problem this way, you can tackle it and get it right. So 42 miles for Saturday. Okay. All right. So let's see. Saturday, she skied 21 miles. And Sunday, she skied. Oh, nope. It's not right, is it? Yeah, let's get that right. It was 42 and 20. It was 42 for Saturday. $42 Sunday, 42 Saturday, and 21. All right, we'll do one more. I'll leave that fourth one for tomorrow, and then we'll get to the assignment. Okay. Again, the main focus on today's Delta Math is reading the problem, setting up two variables, and then writing the equation. We won't be the solving. Okay? You guys ready? Last one. Okay, number 3. This one deals with darts. Very popular in England, by the way. Did you know that? Has anyone ever played darts? It's a lot of fun.
Oh, no, not when you hit yourself.
Yeah, don't do that.
No, when you miss it. Like the thing.
Okay. We all have our dart war stories, I guess.
When you hit your brain.
Especially that. Bryson and Lily played a game of darts. Lily scored 4 more points than Bryson. The total of their score was 180. How many points did Lily score? How many points did Bryson score? Okay. So that's what we have to answer. So let's start with that. Let's start with how are we gonna use our variables? What do they represent? Points. Yep. So let's say we have Bryson. We'll use a capital B. And that's points for Bryson. And L, I'll use capital L for Lily. Okay. So let's come up with some equations. Let's see. Lily scored 4 more points than Bryson. Lily scored 4 more points than Bryson. We could set up an equation from there. Yes. So Lily scored more points. How many? So we have Lily L. Well, equals. That's a funny equal sign. Let's Lily's points equals 4 more than Bryson's. So if I take Bryson's points, well, 4 more. Whatever Bryson scored, she scored 4 more. So what would we do if it's 4 more? It's not 4 times as many. It's just 4 more. Yeah, addition. So Lily's points equals Bryson's plus 4. That's how you would say 4 more. Lily scored 4 more than Bryson. And then here's another one where we're totaling things up. The total of their points, the total of their scores was 180. How would we set that up? That one we've done a few times now. So you take Bryson's points plus Lily's points, and that equals their total. And it's how much?
180.
180. Okay. So let's go ahead and solve. So again, I can go ahead and take this part that L equals and replace it into the other equation for L actually. So it's going to go right there for L. So we're going to replace L with B plus 4. So let's do that. We're going to say B plus no longer L, but B plus 4. Equals 180. Okay. And let's combine the like terms, which are B plus B. So if you add B and B, you get 2B plus 4 equals 180. It's a 2-step equation now. Let's take away 4, divide by 2. Let's do it. And 2B equals 176. Divide by 2. I'm going to write it here on the side. I'm kind of running out of room. So Bryson's points equals 88. So now we know Bryson, his score was 88 points. It's really easy to get Lily's points now, isn't it? Because Lily's is Bryson's plus 4, so it would be 88 plus 4. All I'm doing is I'm taking this. That's 92. So Lily scored 92 points. Okay. All right, so let's write that down. Bryson scored 88 points. Lily scored 92 points. Boom. All right. So we'll do these two examples so you see what the assignment is like. Let's go to example 1. So in example 1 here, it says it has a problem. We have to state what the variables are, and then come up with two equations, just like we did on the notes. So let's read the problem here. It says Mila is working two summer jobs, making $10 per hour washing cars and $11 per hour landscaping. Last week, Mila worked a total of 14 hours and earned a total of $145. Write a system of equations that could be used to determine the number of hours Mila worked washing cars and the number of hours she worked landscaping. This is important. This really tells us what we need to set up for our system. So go to the first drop-down menu. Okay. We have some choices here. We have 6 choices. Are we talking about the number of hours? Okay. Total weekly income, rate of each hour. Which one is it going to be?
Number of hours landscape.
Yeah, it says it's talking about number of hours right here. So really, you got to read it carefully. So we're going to go with number of hours washing cars for 1 and number of hours landscaping for the other. So that should help us figure out our variables. If you can use X and Y if you want, or you can use W for washing cars, L for landscaping. I'll use W and L. Now, we got to come up with some equations. Well, let's go back. They tell us $10 per hour washing cars, $11 per hour landscaping. And it also said that she worked a total of 14 hours. Ooh, that looks familiar. Worked a total of 14 hours. Remember how we totaled things up? What would we do when we totaled things up?
We would do W plus L equals 14.
Yep. That's one equation. That deals with the number of hours. So that's one equation. The second equation has to deal with those dollar amounts. Okay, they're telling us she makes $10 an hour washing cars, right? So the total amount she makes washing cars would be 10W, 10 times W. That's all the money she made washing cars. Plus, she makes how much landscaping? 11? So 11 times L would be all the money she makes landscaping. And then that equals, they tell us how much she made total, right? How much did she make total? Yeah, 145. So notice all of this deals with money. $10, $11, $145. So that's our second equation. Let's try it out. Submit that. Boom. And it works. Okay. Let's try the next one. So question number 2, or example number 2. Let's all read it. Oh, what do we got? So we have Lillian has set up a lemonade stand outside her house and sells small cups and large cups of lemonade. Small cups hold 10 ounces of lemonade, and each large cup holds 24 ounces of lemonade. Lillian used 580 ounces of lemonade and sold twice as many large cups as small cups. Write a system of equations that could be used to determine the number of cups sold. So, number of small cups and large cups sold. So if we go to our drop-down menu, what do we want? Price, number, or amount?
And number of small cups.
Yeah, number of small cups. Yeah. So we can do like S and L. Small cups, large cups. Yeah, the question guided us to that. Yes.
I've been on it for like 10 minutes already.
Okay, restart it. See what it does. Okay, so let's see here. So it says the large cups hold 10 ounces. I'm sorry, the small cups hold 10 ounces. The large cups hold 24 ounces. And it was 580 ounces. Can we come up with something from that?
S plus L equals 580. Or
Well, that would be if it was the total ounces in both cups, but this is, yeah, remember there's 10 ounces times the number of small cups. And this is how many total ounces she sold. She sold this many ounces, 10 times S. That's the total number of ounces she sold from the small cups. What's the total number of ounces she sold from the large cups? Yeah, 24L. And that has to equal 580. What else do we have? Anything else? That's one equation, right? 10S plus 24L equals 580. Anything, any other information there that could give us another equation?
define the variables that you use to make the system.
Yeah, but we're looking for some information within here.
The small cups and the large cups.
So twice as many large cups as small cups. Twice as many large cups as small cups. What did she sell more of? Large cups, right? How many times as much? So L equals 2 times what? Yeah. The large cups equals twice the number of small cups. Try that. So your job is to try 8 of these or do 8 of these on your own. Okay, and for those of you at home, that's what you have to do too.